Awesome. Welcome to this lesson. So in this lesson, we are going to be learning about solar panel sizing. Okay. So in previous lessons, we have done about energy auditing, okay, load analysis, where you get to calculate the exact amount of load, energy requirement for a home based on the appliances they are going to be powering with solar energy. Now, also, we have done our inverter sizing, where you get to calculate the capacity of inverter that can be able to power a home based on the load analysis. We have also done the battery bank. The battery bank will help you ascertain, okay, the capacity of battery that will be able to power the load need, okay, based on the load analysis that we have conducted. Now is for us to conduct what is called solar panel sizing. This will help you ascertain capacity or the amount of solar panels that will be able to fulfill an energy need for a home or for a use. Okay, this said, all you need to know is that the need for solar panel sizing, the need for solar panel in solar system is to be able to generate enough energy that can power a daily energy use. Okay, to be able to generate energy that can cover daily energy use. So what you ascertain on based on your load is, okay, the need to be able to conduct solar panel sizing is so that you'll be able to provide, you'll be able to make recommendation, you'll be able to suggest, okay, the exact amount of solar panels that can be able to take care of that solar energy need. Okay, so that is the essence. Very, very important. So anything you do outside of this, if you have an energy need and you have a solar panel that cannot cover that need, your system is undersized. Okay, so if you also have an energy need that you are now recommending a lot of panel that is above sizing the system, which is going to acquire a lot of cost, which is going to incur cost for the client. But here we are going to work with the load analysis we have done, the energy auditing we have done. With that, we'll be able to determine, okay, the capacity of solar panel that we can recommend or that we can use to be able to power that solar system. So with this said, there are important factors you need to put into consideration when conducting solar panel size. Okay, first, okay, you need to work with your daily energy required. This is what you get. You get this from your load analysis. So all these informations are all there. It's not something you work out. It's not something you substitute or you do some arithmetic calculations to come about. You have already gotten this information when you did your load analysis. So this information, you note it down. So another information you need is the peak sun hours in your area, in your site area, okay? Because that will determine the capacity or the energy you get from the sun. So this information is very, very important. If you size a system with with high peak sun hours, whereby in your client site you have a low peak sun hours, the system will underperform. So ascertaining the peak sun hours of your area is very, very essential. Okay, so also have to add system loss. Okay, system loss is always there, so you have to add it. There are some criteria. Okay, your solar panel cannot deliver 100% of its efficiency, so it's necessary to add system losses to make sure you cover up all the aspect of energy loss processes that goes through from transmitting from solar panel transmitting the energy from the sun to your inverter and batteries and all that. So you need to accommodate all these things for efficiency. So with all this information, you can now come down to deciding the numbers of panels you want to work with. Okay, but then by then you have gotten the information, the main capacity of solar panel you need for that system. Once you have done that, you can now decide the numbers, okay, going by the wattage, going by the sizes you want to use on the system design. So basically, you need these information. These are the important factors for you to size the solar energy. And in this case, we have already done our energy auditing, okay, earlier on. So our energy here we are going to be working with here is 12,450 watts. So these are our energy, okay. These are our required daily energy, 12.4 kilowatts hour energy. That is what the home use on a daily basis, going by all the appliances they run and the hours they run it on daily basis. We arrive at this number. And working with Abuja, I stated that our peak sun hours here is 4 hours. Okay, is between 4 to 5 hours, so I work with 4 hours for efficiency. Then our system loss, we are adding 30%. within 20 to 30%. So we are going to be using 30% for transmission, for inverter conversions, or so charge controller conversions and all that. There are going to be some energy losses there, so we are going to put it at 30%. After that, we'll now determine the size of the panel. Okay, so before we go that, let me show you, let's kind of review panel reading. When we did solar panels earlier, when we talk about panels and all types of panels and how they function and all that, we kind of explain how you can read solar panels, okay, and also how you understanding the information that are placed on the solar panel specification. But for the sake of sizing, I don't know also so that you have an idea the information you need, okay, when siting a solar panel, the information you need to work with, okay, to come up with reasonable data that are going to be useful for you on your solar sizing conduct. Okay, so there are three major parameters, okay, you can use to rate solar panels. One is the wattage. Okay, panels comes in watts. Okay, 20 watt, 50 watt, down to 720 watts. Probably find 750, hopefully maybe 900. But the highest I've seen or work with here is 750 watts. But just know that is the ranges of solar panel watts. Okay, so panels also are rated in voltage. Panels are rated in voltage from volts. Starting from smaller panels, you can even find 1 volt, 3 volts, 12 volts, which is normally used in solar system for home, then 24 volts to 48 volts. These are voltage of solar panels. So they are also very important. The voltage of panels are very important. Okay, also have ampere of current. So these are the currents that each solar panels can transmit. So solar panel, depending on their size and capacity of how they are built, they are going to come with different ampere. Okay, so you read these informations on the back of the panel. Now let me show you a solar panel to show you. Now look at this. Okay, you see this now. This is the maximum power of this solar panel, 200 watts. So this is the information you're going to work with. We also have this one, maximum power voltage. This is the main voltage of this solar panel. We also have what is called the maximum power current. This is the current of this solar panel. So when it comes to reading solar panel or working with solar panel, this is the main informations you are going to focus on. So we also have open circuit voltage, short circuit current, and all that. Now these two informations tells you your limitation with this panel. So whatever calculations you are doing, it tells you that these panels has the potential, okay, to reach this voltage, and it also has the potential to reach this 9 voltage. It's something you just note down and put into your consideration when working with solar panels. But when you want to do your calculations and all that, this is the information. These two information is what you work with. Okay, the maximum power, the maximum voltage, and also the maximum power. Okay, so let's look at basic reading of solar panel. So if you want to read solar panel with these three information I showed you earlier, the maximum power, voltage, and current, okay, with these three informations, if any of the one of the three, if any one of the information there is lacking, let's say they gave you a specification for a solar panel, they gave you the voltage, but they gave you the current, but they did not give you the wattage. With this information you can determine them. Okay, all you just need to know how to substitute them in each of them. Now let's look at how do you ascertain maximum power, that is the wattage of a solar panel. It's simple. If you do the voltage at maximum, you times it by the amp current, you will get the maximum power. Okay, for example, what is the wattage of this is the maximum voltage? The voltage is 213, 23.21 volts, and the amp, the maximum is 8.6 to 62 amps. So if you do this calculation, simple calculation, to get the maximum power is 23.21 volts times 8.62 amps. You get the wattage, just like that. Now let's take another example. Let's look for voltage now. Let's say, for example, they gave you wattage, and to get the panel voltage, you divide the wattage by the amp, you get the panel voltage. Same thing, they give you the amp on the current of the solar panel. They gave you wattage, they give you voltage, but they don't give you the amp of the current. If you want to get the current of the solar panel, you do your maximum power, which is the wattage, you divide it by the voltage at maximum, you'll be able to get your amp, which is 200 watts divided by 2.3 or 23.21 volts. You'll be able to get the amp current. So these are ways you read panels. These are ways you come up ascertain information. This information are very, very necessary. Okay. So once you know how to read your panels and do all these basic calculations to ascertain these informations, let's look at some of the system losses we talk about. What causes system losses? So these are some of the things that causes system losses. Okay, heat. So we also have panels. Okay. So we also have cable losses. So we also have charge control losses. So we also have inverter losses. So these are the reasons why we allocate up to 20 to 30% in terms of system losses when you are doing your calculation. This helps you to stay in a safer mode. This helps you to design more efficient system. So with all this said, let's try to size our solar panel for our solar system. Now, what is our working factor? So these are working factors. Our daily load here, based on our analysis earlier on, is 12,450 kilowatts. Okay, this is 12,450 kilowatts. Okay, so we also have peak sun hours. So our peak sun hour here is 4 hours. That is what we are working with. Then also our system loss, we are going to be working with 30% on these issues. Okay, so let's get started. So what is the required energy from solar? So in this case, we have about 45 kilowatt. So what is the capacity of solar energy we need? Okay, what is the capacity of solar energy we need to be able to meet this need? And how do you go about that? We apply a formula. Solar panel capacity needed equals to, we need this information in watt. What is the wattage of the solar capacity energy we need? Okay, so this is how we go about it. We are going to do our daily load. Okay, you divide it by peak sun hour. Daily load, the load the system is required, the daily load of a solar system design, you divide it by peak sun hour. With this, you'll be able to know amount of energy that system, amount of solar energy your solar panel is supposed to be producing in every 1 hour to be able to sustain that system. And these are our calculations here. We substitute the value. So our daily energy is approximately 12,500 watt hour. Our peak sun hour is 4 hours. So if we divide this, so we need a solar energy. In total, we need a solar energy that will be able to produce 3,125 watts every hour, going by the 4 peak hour. So if we have a solar panel that is going to be able to produce this amount of energy, in every day within 4 hours, we'll be able to generate the energy we need to cover for the day. That is the ideology. So with this said, let's add our system loss. So our system loss is 0.3%. So if we substitute this 0.3% to this figure, so we are having 938 watt hour. Okay, so in our system loss, so we are going to add it. So if you add this system loss to it, okay, so this is the required energy you need. Okay, so under perfect condition, this is the solar energy you need to produce to be able to take care of this system design, to make sure that this design is working perfectly. Okay, so you don't have a single solar panel that can produce 4,063 watt hour. Okay, you don't have that kind of solar panel, but this is the total energy you need to produce. How do you go about ascertaining the numbers of wattage you need or pieces of panels you need? So once you have gotten this figure, everything is settled. All you need to do now is to substitute. So how do you determine the numbers of solar panels you need for your solar system? It's simple. We already have the figure, the amount of energy we need to produce in hourly basis. If we do this for 4 hours every day, we are cool. So how do we go about it? To determine the capacity or the quantity of solar panels we need for this system, it's simple. We divide our figure by the wattage of panel you want to work with. For example, if I'm going to work with 400 watts, all I need to do is to divide this figure by 400 watts, and I will get, okay, the numbers of panels of 400 watt panels I need for that system. If I'm going for 500 watts, I do the same thing. I divide our total solar capacity by the wattage I'm working with. I will be able to get the numbers of panels I will be working with. Okay, if I'm going for 600 watts, I divide it by the total capacity of solar panel. I will be able to get the number of solar panel I'm I'll be working with in that situations. Okay, so basically that is how you go about to any amount of wattage you want to work with. You'll be able to determine the numbers. Okay, so I always I'm putting this 10 to, okay, this 10 to here is more for efficiency. So if you are designing a system like this, you can either work with this or this. Now it's preferable to go beyond. The reason you can add more extra or use a range, or for example, instead of now this 400 I'm going for 12, is to put room for efficiency. For example, cloudy weathers, on period where there is no much suns and all that. Extra panels here can make the system more efficient. Okay, so that is basically it. Now this is how you size a solar panel. So take note. So the most important thing about sizing your panel here is to know your daily energy used, then know the intensity of sun in your area, in your site area. Know the peak sun hours. Very, very important. These are the two major important factors that will help you size your solar panel. Then also remember to add your system losses. Okay, and basically if you follow through these steps, you'll be able to size solar panels for your energy need regardless. So it doesn't matter the capacity, it doesn't matter the location. So all you need is these datas. These datas, you'll be able to arrive at a reasonable informations that will help you size your solar panel properly, and you'll be able to deliver an excellent work to your client. Okay, so basically that is it. That is it on sizing solar panels. Okay, so if you have any question in regards to this, make sure you leave it on the comment sections, and I will see you in the next one. Bye.